So hi everybody and welcome back to C++ tutorial series for absolute beginners. This video 323, and in this video we continue with our value category exercise, and we stopped here at number 25. And like all time, you read the question, you pause the video and try to answer as good as you can, and then you start the video again and compare it with my answer. And like all time, I don't pause, I just go straight to the answer after we read the question. And let's get started. We are here at 26, and it says here an enumerator. First of all, what value category an enumerator has, and make a code example. So you pause the video, and like I said, I don't pause, I just jump to the answer. So first of all, an enumerator has the value category PR value expression, but here side note, you must be careful because it is only a PAR value expression when you call the value of the enumerator and not the enumerator variable when you created one before. We will see in a moment in a code example. And here are my code example. I will show you actually Stack Overflow example because they are asking a nice question there, and we're jumping not right there because I want first talk a little bit again about the enumerator. We repeat very fast so that we know what an enumerator is. I hope you remember an enumerator is a way to declare your own type with your own values, right? And important here to note is we know two kinds of enumerators, right? The one is the unscoped enumerator. That was just when you use the word enum without struct and class. And the other one, this is the scoped enumerator, and this is the more safe version when you have your enum and then struct or a class and then the name of the enumerator, which is the type. So I hope you remember this kind of stuff, and I won't talk here a little bit more because this enumerator belongs to this special kind of structures which can called without an object. And this is all time so a kind of little bit confusing for starters what I mean with that. So normally here's a little code example. Let's talk about this fast. So you can see here we create a struct X, and in the struct is just one enumerator declared, and this one is the unscoped version because we have just the word enum without struct and class. And then you can see here they create a object X, and then they create here a pointer as well to this created object X, and here are examples. So this one looks already a little bit strange. So you call X, okay, you call the class with the class resolution operator, okay, then direction, you call this one directly, and now you call left. So here what's interesting is at this point we have not declared an object, so it is not using this X here, it is just calling this one directly and then assigning it to a variable, an int. And here again, let's repeat this one as well. What is the problem here? Why normally this is also a little bit confusing. Wait a minute, we have here a struct, we have here declared our own enumerator with our own variables, and then we are assigning to an int. And that was the problem, which and it's not a problem, it's definition, right? The unscoped enumerator, all the values which you declare, for example here red, green and blue, they have a underlying type, and by default this underlying type is int. But this type we know you can also specify here, for example when you see the second version, and then you make here for example this colon and then specify the underlying type a little on your own. But without specifying anything, they have an underlying type. It starts here as an example for it starts here A, B, C. Okay, these are the these are the letters, but the underlying type is A is equal to 0, B is equal to 1. Here you think, wait a minute, why is C 10? Because the underlying type here is defined to 10 with this special specialization. You can see the assignment and so on, but important is it has an underlying type, and that's why we can make here an assignment from here an enumerator to a int variable. And the important part you to note is this works only with the unscoped, and the scoped version, which is considered to be more safe because it has not this underlying type conversion, which means when you have here enum struct or class, which let's go back to our example. What was here? Let's go here to this one, which means if this here would be an enum class or enum struct, this one would not work. Why not? I mean, the call would work perhaps, but this one would not work to assign it to an int because the underlying type is not allowed. So keep this in mind. That's why they consider this scoped enumeration more safe, but of course we have to know both because this one you will see a lot as well. So okay, that was that. Let's continue a little bit. And so here again you can see we can call again this left here, for example, the value, without creating here on the second example as well without an object. So without x, they called it just and then assigned the value, for example, to a variable b. And here is the normal way what you expect how it works. The normal way, like all time, you have a variable, you have here a struct, and then you create a variable x, and then you call this variable left, for example. In this case, this is the normal way. And yeah, and this is the same thing with the pointer version. So that is one of the specific thing what I want to mention here as well. And when we go here to ChatGPT, I have wrote here this C++. It is possible to use a class without an object. I wrote it this way because I wanted to list you all the other versions as well. We are not going through them, but keep in mind you can call classes sometimes without creating an object. Here is an example with static. Here is an example with, again, static actually, but yeah. And here is an example that what we had just right now with the enumerator. And here is an example with, yeah, you can see that, so on. That's not in, so just keep it as in mind. And I'm pointing this out because this can be confusing when you see, hey, wait a minute, where is your object? And so, all right, let's continue. That was enough for us enumerator repetition. Again, when you have an enumerator, one more thing perhaps, most of the time what you are using with an enumerator is a switch, because you have here an enumerator, you have defined your own variables, and then you can make here a switch and then react on the condition what you have here very comfortable. Yeah, let's continue now with our example from Stack Overflow, because when going to a Stack Overflow here, he is asking here a question, this person, why is here an L value reference? Because he expected, like we defined, like I said here in our example, an enumerator, right, is a P value expression. But in his example, he tested this one and he get an L value reference. So how he tested this, let's watch this. Is a nice example. You can see he starts here creating an enum class color. You can see here, let's repeat here also, this is a nice example. So again, here it's the scoped version, the class, which means the underlying type will be not automatically converted, but you can see he is changing the underlying type as well to a char. All right, that's okay. And then he is creating a struct, okay, and he is just defining a variable color, which is his type, which he created here, and he creates here an object with C. Okay, so far nice. And these two cases, these two functions are the test. How he is testing that? So you say, okay, I call a function, and then I call the color, and then one is an PR, so an R value call, because we know this with double ampersand, it's an R value, and the other one is an L value. We know this as well, an argument with just one ampersand is an L value call. So you can see this is the test here which he is doing, and then you can see what he is doing is here is he creates test T. Okay, he creates an object of this struct here, and then he called a function. This is a function, and depends on the argument which he is passing here, one of them will be called, and we know it is called a function overload, which means the compiler will choose, depends on the argument here, one of them. And in his example, so you can see T and then C is called, and the compiler is calling here the L value version, which is this version. And then he is asking, yeah, why? And that's why I wrote here also careful, not the variable call, because exactly that happens here. He is not calling with the argument TC. Let's watch this again. T is the object and C is a variable, right? Because this is the type, this is just a variable which he created in this one, and this is a variable call and not a value call. And here when we go down, here is another explanation. You can see he's also pointing this out, that you have to call the value directly, not the variable. Or here, even better, here the same thing like before, similar. He made also the struct test. He made also here enum color. Okay, the only thing what he made here is the unscoped version. He used the scoped, here is using the unscoped version, and then he is also defining the color C in this test. And here again the two test functions. And important here to see is again he is creating the object test T2, but here the most important part comes here. He calls the function T and he calls not the variable. So the C would be the variable, but he calls T. This is the object which he created. So he's calling test or T object, and then directly the value. So not careful, this red here is not a variable or green. These are values of this type, and this one is here called directly, and this one here's a PR value. And this, this is you have to know this, because if you are calling accidentally the variable, the L value will be called. That's it. So that was all for this one, and like all time, if you have any questions, write in the comment section. See you on the next video. Bye, good luck, and like all time, never give up.